Okay, this is 8th grade activity 4.2. The objective today, students will develop an understanding of discrete and continuous domains by exploring familiar problems. The standard covered in this lesson is 8F1 and 2. The page numbers out of the hardcover book are 154 through 159, and out of the practice journal, pages 81 through 84. So today you're going to need your practice journal for this activity. We'll go through all of the parts together. Okay, today go ahead and open up your books to page 81. So on page 81, we're going to review through a story problem that we actually worked with back in chapter 2. So it says in activities 1 and 2, so this is number 1, in section 2.4, you studied a real life problem that represented this same equation. So here, if you look at the tickets that you have on the right-hand side of the screen here, we've got these tickets that were being sold to whether looks like a music concert or something. And it says on there that adults are $4 and children are $2. So that's telling us how much each one of them costs. So when the equation was written, our adults represented the X. So if we had $4 per adult, we could figure out how much it would cost us. And then your children was the 2Y. So it was $2 per child. In this scenario, we could only spend $16, okay? So what we did is, when we did this the other day, we went through and figured out all of the possible situations that could actually happen. This is what we call our function form. So you could go through the process of that 4x plus 2y equals 16 and work to get y by itself and represent that in function form, which is y equals negative 2x plus 8. Okay, so in section 1 of chapter 4, we discussed domains and ranges, also known as inputs and outputs, or your x and y values. So in this graph, our domains, well, those were our x values. So this domain was 0. So that's how we have this 0 here. This domain was 1. Okay, and these x's represented our adults. And these are our child tickets. Okay, so the rest of our domains were 2, 3, 4, and so forth. Okay, so we only could go out through 4. That's where our line ended. Now, the reason we could only go out through 4 is we could only spend $16. So we could only buy 4 adult tickets at $4 a piece for the $16. Okay, so now we also have our range. So our range are our y values, or in this case, it was our child values. So we could buy 8 child tickets for $16. Okay, we could buy 6 child tickets, and then, of course, an adult ticket. We could buy 4, and then some adult tickets, 2, and some adult tickets, and then we could also buy no child tickets and then have to buy 4 adult tickets. So those are our domains and ranges, our inputs and outputs. Okay, this is an example of a discrete domain. So what does discrete mean? Discrete means it only can include those numbers. So when you're looking at your domain, okay, how do you determine if it's discrete or not? You think about the situation. So this situation is talking about adult tickets. Can we buy a half of an adult ticket? No, we cannot. So that's why you'll notice that in our graph here, these dots are not connected by a line. Okay, they're not connected by a line because we cannot buy a half of a ticket or 1.5 of a ticket. If we were to connect this with a line, we would be saying that everything that would fall on that line is a possibility for the domain. And that is not true in this situation because we cannot buy a part of a ticket. So this is what you would call a discrete domain. Okay, so we're gonna go ahead and go over what a continuous domain is. Okay, so here's another scenario that we actually worked with back in chapter 2 also. So back in chapter 2, we discussed buying cheese. Okay, so here, once again, we went through and we spent so much money on this cheese. And when we wrote out our equation, this is what we could buy: 8 pounds of cheddar cheese and 0 pounds of Swiss cheese, or we could go all the way out and buy 4 pounds of Swiss cheese and 0 pounds of cheddar cheese, or we could buy anything in between. Okay, so you'll notice that in our little table off to the side here, they're telling us how much each pound of cheese costs. Okay, so this is what you would call a continuous domain. So continuous, what's the difference? Continuous means we could buy a partial of either of those, of either of the scenarios here. So we could buy a partial pound of cheddar cheese. We could buy a partial pound of Swiss cheese, and that's okay. That is a possibility. So when we do a continuous domain, we connect all of our dots, or in this case, just our beginning and our ending dots with a line, meaning that anything that falls on that line is a possibility. We could buy a half pound of cheddar cheese, and we could still buy some Swiss cheese also, okay? So as we go through this, as you're working through continuous domains, well, we can no longer just say that it's certain numbers, because it's going to contain everything that falls in between. So this is the way that you would show a continuous domain range, okay? So what does that mean? It means that we could buy, for X, we could buy for Swiss cheese more than a pound, but we could not buy more than 4 pounds. So it would have to fall between 0 and 4 pounds. Okay, that's what this is representing. Okay, so our range for our cheddar cheese, well, we could buy all the way up to 8 pounds, or we could buy 0 pounds. We could fall anywhere in between. So this is just meaning that Y could be greater than 0 pounds or equal to 0. And it could also be less than 8 pounds or equal to 8, but it could not go above that, okay? So this is what you would call a continuous domain. So continuous domain means we would include anything in between our two ranges, our start and our stop. Okay, the key thing is when you're working continuous and discrete domains is understanding what the scenario is, and you have to understand the scenario. Okay, so we're gonna go ahead and work off of one. So page 82 of your practice journal, we're gonna write a function, we're gonna graph that function, and then we're gonna describe the type of domain. Okay, so it says you're in charge of reserving hotel rooms for a youth soccer team. Each room is going to cost $69 plus $6 tax per night. You will need each room for 2 nights. So no matter what, we're staying for 2 nights. So let's first of all figure out, if we're gonna stay for 2 nights, how much is that gonna cost us? Well, it's gonna be $69, then plus another $6 tax. So that's a total of $75 per night. Now, they told us that we're gonna stay for 2 nights no matter what. So we're gonna go ahead and just go times 2 to see what we would spend on one room. So when we do that, it's gonna cost us $150 for the 2 nights per room. Okay, so our equation, well, our X is our number of rooms. So our equation, or our function equation, is our cost, Y, is going to equal, well, it's going to cost us $150 per room. So we're going to put in X. So that's our equation. Now it's telling us that we will need to get anywhere from 10 to 16 rooms. Okay, write a function. So we already wrote our function. Okay, so now what we're going to do is we're going to go ahead and do our domains and our ranges. So obviously we're not going to start with 0 because we're not going to buy 0 rooms. We're not even going to start with 1. They told us that we're going to have to get a minimum of 10 rooms. So we're going to start with 10. Okay, so if I substitute 10 in place of X here, and yes, you can use a calculator if you need to. So if we do 10 times 150, that's going to give us $1,500. So if we just get 10 rooms, it's going to cost us $1,500. Okay, so we might need 11 rooms. So we're going to do 11 times 150. And when we do that, we get $1,650. Okay, you're creating the same table underneath of your graph on page 82. Okay, so maybe we need 12 rooms. Just going to depend. We need to make sure that we have the right number of rooms. So 12 rooms times $150 is going to give me 1,800. So we'll continue in that pattern. 13 rooms times 150 is 1,950. 14 rooms gives me $2,100. So 15 rooms is going to be 2,250. And then 16 rooms is going to be $2,400. Okay, so this is our domain. This is our range. Okay, so now we have to decide if that would be a discrete or a continuous. So if we go through and we graph this out, and I'm just going to graph the first couple, and then to save time, I'm going to pull my graph out. So I'd go over to 10. Remember, those are your X's, and then up. So if I'm graphing this one right here, up to 1,500. So over to 10, up to 1,500. Okay, and I'm gonna do each of my dots, and then we're gonna decide, do we connect the dots or not? Okay, so now I'm gonna go over to 11, which is in the middle of these two boxes here, and up to 1,650, so 1,650 falls right in the middle of that box. Okay, then over to 12, up to 1,800. Okay, so we're gonna continue in that pattern until we have all of those graphed. Now, I need to decide, would this be discrete or continuous? So to decide that, we have to think about the situation. So if it's discrete, that means we cannot get a partial of either of these situations. Could we buy a part of a room? No. So if you cannot buy a part of a room, then you are not going to connect these, because you can't, when you connect them, you're saying that it would be anything that would fall on that line. So that would mean that anything that would fall in between these two dots here would be true. And that is not a true statement. We cannot buy 10 and a half rooms. Okay, so this is what your graph should end up looking like in the end when you finish it out. Okay, notice that we did not connect the dots because we can't buy a part of a room. So discrete means we can only buy exactly what's there. We cannot include anything in between those two. Okay, so that's working with a discrete domain. Okay, so now we're gonna go ahead and do a continuous domain. Okay, so a continuous domain, it says, the airline that you are using for the soccer trip needs an estimate of the total weight of a teen's luggage. You determine that there will be 36 pieces of luggage and that each will weigh anywhere from 25 to 45 pounds. Write a function for the total weight of the luggage. Okay, so first of all, let's discuss out whether it's going to be discrete or continuous. So if we know for sure we're going to have 36 pieces of luggage, we can't have a half of a piece of luggage. But could we have a luggage that would fall maybe at 25 and a half pounds? Could that possibly happen? Yes, it could. So granted, we can't take a half luggage, but we could have luggage that would fall in between like two certain pound measurements. So this would be what you would call a continuous domain. Okay, so no matter what, if we go through and we look at this, when we look at our domains, if we look at just our domain numbers, so our X's, and we look at this number, could it fall in between? Do we have to have exactly the pounds stated, or could it fall between 25 and 26 pounds? If we can answer yes, then that would be a continuous, meaning that as we plot these, we're going to go ahead and connect our dots. Okay, so our domain, okay, it can go anywhere from 25 pounds to 45 pounds. And X can fall anywhere in the middle. So we're going to go ahead and put our X in the middle. And now we're going to have to use those symbols. And I know that this is continuous when you're writing out the domain. It's kind of confusing. But when we do this, it would be X could be greater than or equal to 25. Or it has to be less than, sorry, I got to switch that around. Or equal to 45. In other words, it can't be more than 45. Okay, so we're saying by using that less than, greater than, less than, greater than, or greater than, equal to, sorry, that it's going to fall in between 25 and 45 pounds. Okay, so now we need our range numbers. Well, if it was 36 pieces of luggage, what's the least amount that it could weigh? So if we have 36 pieces of luggage that each weighed the minimum amount of 25 pounds, let's go ahead and multiply that out. So 36 times 25 is going to give us 900 pounds. So it could fall, 900 pounds is the least that it's going to weigh. Okay, we're going to put our X in the middle. And then what's the most that it could possibly weigh? Well, we would have 36 pieces of luggage that could weigh up to 45 pounds at the max. So we're going to do 36 times 45 to see what's the most all 36 pieces would weigh. And that would be 1,620. Okay, so there's our range. So I know it's kind of confusing when you do the domain and the range of these. once again, put your X in the middle of your smallest and your largest, and then you're going to use your inequality symbols to do that. So now if I'm going to go through and actually graph this out, well, I'm going to go, remember, these are my X's. So I'm just going to graph this part out and this part out. So I'm going to go over to 25, which falls in the middle here, and up to 900, 25 up to 900, approximately in here somewhere. Okay, because there's a 250 point gap between every single box. Then I'm going to graph my second one, which is 45 and 1,620. So over to 45, up to 1,620, which is going to be somewhere in here. And then we said that this was going to be continuous, meaning that anything that fell in between those two measurements could be possible. So we're going to go ahead and connect it with a line. Okay, here's a better picture of our graph. Now, I only graphed the two scenarios that we had. I'm going to erase that so that you can see the actual ones. I only graphed these two, our smallest and our largest, but you could really pick any numbers in between there if you wanted to graph on every line so that you could see that. But here it's just showing that every possibility between 25 pounds and 45 pounds would actually fall into place. Okay, so that's a continuous domain. Okay, that is pretty much it for this activity. So we're going to work some more with this in our lesson. The key thing on this is continuous means you're going to have a line involved in your graph, which means anything that falls between your plotted points would be included as an accurate statement. And then your discrete domain would be where you just have dots and you do not connect them, meaning those are the only points that would satisfy the equation.